Hello friends, today we are going to see numerical on series magnetic circuit. Let us see one example. An iron has a uniform cross-sectional area of 5 cm square and mean circumference of 25 cm. A coil of 120 turns is wound uniformly over the ring. When the current in the coil is 1.5 ampere, the total flux is 0.3 milliweber. First, calculate magnetic field strength and relative permeability. Second, if there is a cut made in the ring having length of 1 mm, find out the amount of current to be passes through the coil to produce the flux as before. Neglect fringing flux. So let us consider first case, iron ring without air gap. So figure shows this diagram. Now first aim is to convert the cross-sectional area which is given in cm square to meter square. Then convert length which is given in cm to meter. Then convert unit of flux which is milliweber into weber. Then convert the length of air gap unit which is given in mm to meter. So let us find out first flux density. Which is equal to B equal to phi by, so phi it is given as 0.3 milliweber, so convert it into weber, 10 raised to minus 0.3 into 10 raised to minus 3 divided by area 5 into 10 raised to minus 4 meter. So finally we get is equal to 0.6 weber per meter square or Tesla. Now let us find out magnetic field strength. Is equal to capital H. It is equal to mmf divided by length. mmf is nothing but I into n divided by length. So it is equal to, therefore H is equal current, it is given 1.5 ampere, 1.5 multiplied by number of turns are 120 divided by length, it is 25 into 10 raised to minus. So here we get final answer as 720 ampere per meter or ampere turn per meter. After this, let us find out relative permeability. We know absolute permeability mu, it is equal to E by H, but mu it is equal to permeability of free space multiplied by relative permeability mu r. Therefore mu r is equal to relative permeability equal to E divided by mu 0 into H. So it is equal to B, which we calculated in step number 1, 0.6 divided by mu 0 is fixed 4 pi into 10 raised to minus 7 multiplied by H is 720. So finally we get mu r equal to 663.15. Now in second part, the iron ring with air gap. Make a cut of 1 mm this iron ring. Therefore Lg is equal to 1 mm. Now with this, the iron length get changes and therefore calculate length of iron part. it is equal to Li. It is equal to total given length 25 into 10 raised to minus 2 minus 1 mm is 1 into 10 raised to minus 3. So here it is equal to 0.249 meter. Once we calculate it, then find out mmf for iron ring. It is equal to mmf I is equal to hi into Li. We calculate this h in first part. So take that value 720 multiplied by Li, that is 0.249, new length of iron path. So here we get mmf for iron ring equal to 179.28 ampere turns. So let us find out flux density in air gap. So it is equal to flux density in air gap. So it is equal to Vg equal to, now according to given problem, phi remains same, area it is same. So by calculation we get it is equal to 0.6 Weber per meter square or Tesla, which is equal to flux density of iron. Now let us find out field strength in air gap. So magnetic field strength in air gap. So it is equal to say Hc. It is equal to Bg, that is flux density in air gap, divided by mu 0. So it is equal to Bg is 0.6, which is equal to flux density of iron, divided by mu 0, it is fixed 4 pi into 10 raised to minus 7. So it is equal to 0.477 into 10 raised to 6 ampere turn per meter or ampere per meter. Once we calculate this, let us calculate mmf for air gap. Let this be mmf. So it is equal to Hg multiplied by Lg, that is magnetic field strength multiplied by length of air gap. So it is equal to 0.477 multiplied by 10 raised to 6 multiplied by length of air gap. It is 1 into 10 raised to minus. So it is equal to 477 here. Now we have mmf for iron ring, we have a mmf for air gap. So let us calculate total mmf. Therefore total mmf, it is equal to mmf T equal to mmf for iron ring mmf I plus mmf of air gap, mmf so it is equal to mmf I is 179.28 1.20 plus mmf G is 477. So here we get total mmf T, it is equal to 656 656.28 ampere. Once we calculate total ampere turns or total mmf, we can easily find out current flowing through the coil. Therefore, total mmf is now equal to N into I. So, is equal to N into, where I is the new current. So, N into I, it is equal to 656.28. Therefore, current I, which is flowing through coil now, equal to total mmf 656.28 divided by number of turns, that is 120. So it is equal to now 5.8